The residuals from fitting a straight line to data can be used to compute confidence intervals and do hypothesis tests for the parameters of the best fit. Here again is the sample data and the best fit from the previous section. This uses the best fit parameters property of the model to get those parameters, which are the intercept and slope coefficients from the formula for the best fit. And this computes confidence intervals for the intercept and for the slope using formulas that are programmed into the computer. The first element in this result gives the endpoints of a 95% confidence interval for the intercept, and the second element gives the confidence interval for the slope. The formulas for these confidence intervals involve the fit residuals. This input gives the residuals for this example. Like other confidence intervals, the confidence interval for the slope is the estimated slope plus or minus the margin of error. The margin of error is a critical value t star, which will be computed using the student t-distribution multiplied by the standard error of the slope. These inputs show the formulas that are used by the computer to calculate the standard error of the slope in terms of the standard deviation of the residuals divided by the standard deviation of the values of x in the data. Using that result for the standard error of the slope, calculation of the confidence interval is done just as for other confidence intervals, except that the value of degrees of freedom in the student t-distribution is n-2 rather than n-1, since two parameters, the slope and the intercept, are fitted to the data rather than just one parameter as in earlier examples. The result is the same as the result obtained earlier using the parameter confidence intervals property of the model. The confidence interval for the intercept can be calculated in a similar way, but with different formulas. Hypothesis testing is closely related to computation of confidence intervals and uses a similar calculation. For example, the test statistic for a hypothesized slope is given by this formula. If the null hypothesis is that the slope is 0, the test statistic is the estimated slope divided by the standard error of the slope. This is the same standard error that was obtained earlier in computing a confidence interval for the slope. As in other hypothesis tests, the p-value is the probability that falls beyond this value in the tails of the sampling distribution of the test statistic. The appropriate sampling distribution here is the student t-distribution with n-2 degrees of freedom. The p-value can be computed using the cumulative density function CDF of that student t-distribution. Conditions for the validity of these hypothesis tests and confidence intervals and for linear regression in general are explored in the next section.